Data analytics is essential for businesses today. It involves the systematic computational analysis of data or statistics. It helps them make better decisions and improve their operations by providing valuable insights. Data analytics uses a process of examining raw data to find patterns, trends, and insights. This process often involves various techniques and tools. These insights help businesses understand their customers, markets, and competitors better, leading to more informed strategies. Data analytics is used in many industries, including healthcare, finance, and retail. Each industry leverages data in unique ways to solve specific challenges. For example, in healthcare, data analytics can be used to improve patient care by identifying trends in patient data. In finance, it can be used to detect fraud and ensure the security of financial transactions. And in retail, it can be used to personalize customer experiences, enhancing customer satisfaction and loyalty. Data analytics is a powerful tool that can help businesses of all sizes succeed by making data-driven decisions. By understanding the basics of data analytics, businesses can start to unlock the power of their data, leading to significant improvements. This can lead to better decision-making, improved efficiency, and a competitive advantage in the market. Data analytics is a rapidly growing field with continuous advancements in technology and methodologies. There is a high demand for skilled data analysts, making it a promising career path. If you are interested in a career in data analytics, there are many resources available to help you get started, including online courses and certifications. There are four main types of data analytics: descriptive, diagnostic, predictive, and prescriptive. Descriptive analytics answers the question, what happened? It summarizes historical data to provide insights into past events. For example, a company might use descriptive analytics to track sales trends over time. Diagnostic analytics answers the question, why did it happen? It goes deeper than descriptive analytics to identify the root cause of an event. For example, a company might use diagnostic analytics to understand why sales have declined in a particular region. Predictive analytics answers the question, what is likely to happen? It uses statistical techniques to forecast future events. For example, a company might use predictive analytics to predict customer churn. Prescriptive analytics answers the question, what should we do? It recommends actions based on the insights from predictive analytics. For example, a company might use prescriptive analytics to develop a marketing campaign that targets customers who are at risk of churning. The field of data analytics is constantly evolving. Here are a few of the latest trends. Artificial intelligence, or AI, is being used to automate data analysis tasks. This frees up data analysts to focus on more strategic work. The cloud is making it easier for businesses to store and process large amounts of data. This is leading to the growth of big data analytics. Data visualization is becoming increasingly important. Businesses are using data visualizations to communicate insights to stakeholders in a clear and concise way. And the demand for data analysts is growing rapidly. Businesses are struggling to find qualified candidates to fill these roles. A data ecosystem is a collection of components that work together to manage and analyze data. A typical data ecosystem includes the following components. Data sources. These are the systems that generate data. Examples include CRM systems, ERP systems, and social media platforms. Data ingestion is the process of collecting data from various sources and loading it into a central repository. Data storage is where the data is stored. Data can be stored on premises or in the cloud. Data processing is where the data is cleaned, transformed, and prepared for analysis. Data analysis is where the data is analyzed to extract insights. And finally, data visualization is where the insights from data analysis are presented in a visual format. Section 5, the data project lifecycle. A data project typically follows a life cycle that includes the following phases. Planning. This phase involves defining the goals of the project, identifying the data sources, and assembling the team. Data collection. This phase involves gathering the data from the identified sources. Data cleaning. This phase involves cleaning the data to remove errors and inconsistencies. Data exploration. This phase involves exploring the data to understand its characteristics and identify potential insights. Data modeling. This phase involves building models to explain the data and make predictions. Data visualization. This phase involves creating visualizations to communicate the insights from the data analysis. Deployment. This phase involves deploying the models and visualizations into production. Monitoring. This phase involves monitoring the performance of the models and visualizations and making adjustments as needed. Section 6. Skills and responsibilities of data analysts. Data analysts are responsible for collecting, cleaning, analyzing, and interpreting data. They typically have a strong understanding of statistics, mathematics, and computer science. They also have excellent communication and problem-solving skills. Here are some of the key skills and responsibilities of data analysts. Collecting data from various sources, cleaning and preparing data for analysis, analyzing data using statistical techniques, developing data visualizations to communicate insights, presenting findings to stakeholders, staying up to date on the latest data analysis trends and technologies. Section 7. Data-driven decision-making. Data-driven decision-making is the process of using data to inform business decisions. It is a critical aspect of modern business and can help organizations to improve their efficiency, profitability, and competitiveness. The data-driven decision-making process typically involves the following steps. Identify the business problem or opportunity. Gather the relevant data. Analyze the data to identify trends and patterns. Develop recommendations based on the data analysis. Implement the recommendations and track the results. Section 8. Tools for data analytics. There are a wide variety of tools available to help data analysts with their work, each designed to address specific needs and challenges. These tools can be divided into several categories, including spreadsheets. Spreadsheets are a simple and effective tool for storing, manipulating, and visualizing small to medium-sized datasets. They are often the first step in data analysis. Microsoft Excel and Google Sheets are two popular examples of spreadsheet software widely used for their accessibility and ease of use. Databases. Databases are designed to store and manage large amounts of data, providing robust solutions for data integrity and security. They offer a variety of features for querying, filtering, and aggregating data, making it easier to extract meaningful insights. Popular database management systems include MySQL, PostgreSQL, and Microsoft SQL Server, each with its own strengths and use cases. Visualization tools. Visualization tools allow data analysts to create charts, graphs, and other visualizations to communicate their findings to stakeholders. These tools help in making data more understandable and actionable. Tableau, Power BI, and ClickSense are popular examples of data visualization software, known for their powerful features and user-friendly interfaces. Programming languages. Programming languages such as Python and R are powerful tools for data analysis, offering flexibility and control. They offer a wide variety of libraries and packages for data manipulation, statistical analysis, and machine learning, making them indispensable for advanced data analytics tasks. Section 9. Data visualization. Data visualization is the process of representing data in a visual format such as charts, graphs, and maps. It is a powerful tool for communicating insights from data analysis to stakeholders, making complex information more accessible. Effective data visualizations can help people to understand complex data sets, identify trends and patterns, and make better decisions based on the data presented. When creating data visualizations, it is important to follow best practices to ensure that the visualizations are clear, concise, and easy to understand for the intended audience. Some best practices for data visualization include: choose the right chart type for the data you are presenting. Different chart types are best suited for different types of data and messages, so it's crucial to select the appropriate one. For example, a line chart is a good choice for showing trends over time, while a bar chart is a good choice for comparing categories or groups. Use clear and concise labels to ensure that the data is easily interpretable. Labels should be easy to read and understand, providing immediate clarity. They should clearly indicate what the data represents. Use color effectively to enhance the visualization. Color can be used to highlight important data points, group related data together, and make visualizations more visually appealing and engaging. However, it is important to use color sparingly and thoughtfully to avoid overwhelming the viewer. Too much color can be overwhelming and confusing. Keep it simple and focused. The best data visualizations are often the simplest, conveying the message without unnecessary complexity. Avoid using too many chart elements or making the visualizations too complex, as this can detract from the main message.